Good morning, pre-calculus. Guess what? We get to start chapter 9 today. Chapter 9 is about sequences, series, and probability. And first thing we'll do is we're going to look at section 9-1. We'll do two parts, so we'll start with part 1 right now. So without further ado, Mudrock, hit the lights. All right, section 9-1. What we're going to do in this section, again, I have here what your section is, what pages we're going to be dealing with in your textbook. Here's our essential question. How do you represent a sequence of numbers or the sum of a sequence? All right, and then here's our assignment. It's also posted for you guys to reveal or to do. So here I've got some of the formulas that may or may not be in your textbook, so get that recorded. And we're going to look at sequences and series. And we're going to look at two different types of sequences and series. One's the arithmetic, and the other is the geometric. And we'll talk about these three formulas, or actually these four different formulas with examples. All right, so let's get started. The first thing we'll do is, just like we do in class notes, we'll do everything in outline form. So the first thing we'll look at is Roman numeral 1, deals with sequences, covering in the book from page 642 to 644. Once again, I strongly encourage you to read your book, follow the examples. You should have no problems. All right, sequences. Now I have up here two examples where the directions say write the first four terms of the following sequences. So here is our first one. A sub n equals 2 times n plus 5. So they want us to find the first four terms, so I'm going to go and let n become 1, n become 2, n become 3, and n become 4. And that will, after we do the order of operations, that will give us the first four terms of this example of a sequence. Same thing over here. B sub n equals 3 raised to the n minus 1. Again, let n become 1, 2. Again, I wrote it down wrong. 3, 4. Do your order of operations, and you get these first four sequences. Now, there is a difference between these two sequences. The first one is an example of what we call an arithmetic sequence, 7, 9, 11, 13. And the one over here of 1, 3, 9, and 27, that's an example of a geometric sequence. Now, the key here is looking at what is happening from what value or what product or what addition is happening from this term to this term. And we notice that from 7 to 9, it's increasing by 2. And 9 to 11, it's increasing by 2. And 11 to 13, it's increasing by 2. And then we could probably just find out that the next term is 15. So again, this one has what we call a common difference of increasing by the same value of 2. So a common difference. And then the formula here says that we want to figure out what this problem is. So a sub 1, which represents the first term of your sequence, added to the multiplication of, in this case, we're dealing the finding of ending up with the fourth term times the common difference. So this equation right here, or this formula, is what they found out to be right here. I'm not doing a very good job here of explaining what you'll see as you plug and chug. Okay. Now, the geometric sequence, again, this is called the common ratio. And the common ratio is looking at taking the second term and dividing it by the first term. So 3 divided by 1 is 3. Then the third term divided by the second term. 9 divided by 3 is 3. The fourth term divided by the third term, that is 27 divided by 9. That gives you 3. So here we see that we have a common ratio of 3. And since all these common ratios are the same, this is an example of a geometric sequence. So what you're going to be doing in this section is, one, finding first, 5, 6. They don't tell you. They'll tell you in directions terms, but what we're going to do is we're going to take a sequence of numbers. We're going to see if it's an arithmetic sequence or a geometric sequence, and find the corresponding formula for it. So let's look at that, okay? All right, so here is one example. I have two on my page here. I'll just look at letter A. Let's write an expression for the most apparent nth term of each sequence. So here is my sequence of 1, 5, 9, 13, 17. Now I've already wrote down that this is an arithmetic sequence, and you're probably saying, how did you figure that out? Well, you look here. So we know from 1 to 5 is 4 units, or addition of 4. From 5 to 9, it's also increasing by 4. 9 to 13 is increasing by 4. And 13 to 17 is increasing by 4. So we see that we have an increase from each respective term for an addition of 4. So that tells me that this is an arithmetic sequence. So to see if it's the most apparent, we already know that our D is going to be 4. We know this problem started off with the first term of 1. We know we're only going up, again in this case, we don't know what n is. N is just going to represent how many terms we're going to deal with, but we don't know what that's the nth term. So if we plug this information that we give in here, we will find out that this sequence of numbers would be a sub n equals the first term plus n, which we don't know what term we're going to deal with, times the common difference of 4. So we can take that part and we can simplify it. So using the order of operations, let's see, 1 plus 4n minus 4. So a sub n will equal 4n minus 3. So that will be the formula that we could use to find any term of this sequence. So let's do an example. Let's see if we did our math right. So this is the 17. That's the 1, 2, 3, 4. That's the 5th term of the sequence. So if I want to find the 5th term of this arithmetic sequence, I let n become 5. 4 times 5 is 20, and 20 minus 3 is 17. So we have found our formula for the arithmetic sequence. Now letter B, a little bit different than arithmetic and geometric. So here I'll let you guys copy that down again and follow the directions on that. All right. So a quick recap dealing with this section. And the part A deals with, for right now, we're just looking at sequences. So again, arithmetic sequence, again, we have to find our common difference. For the geometric, we got to find out what our common ratio is. Now remember, in arithmetic, from one term to the next term, it's always going to have the same common difference. For geometric, from one term to the next term, it's going to have the same common ratio. Okay. All right, guys, that's part 1. Hopefully it was very helpful to you. Please don't be afraid to open up your book. Very, very applicable. Okay. Don't be afraid to open up your book and read. Look at the examples, and we'll catch you later. Bye.